metal react with oxygen, water, and acid. Here is the ionization energy that we learn the trend of the reactiveness of metal losing electron of different degree, of different tendency. And of this ionization energy table, students may find difficult of following this numbering, because this numbering, when you look, sometimes is quite jumbled. And yes, it does give a general trend of the small number on one side and as being the most reactive, as here, and which is the most reactive, and the least reactive onto the other side, and the trend. But this trend sometimes students find it difficult to follow. So here's below is the activity series. This activity series follow nicely to this ionization energy. And this activity series advantage is they are in a nice order from a small number to a bigger number and accordingly to the bigger number. So this activity series, we're going to rely on it instead of using the ionization energy as a bit too hard for a high school student. And the trend of it, now we ignore the non-metal because we're going to deal with the metal topic. And of this activity series will also show, just like ionization energy, as the more reactive metal onto the lower ionization number, and the least reactive metal onto the bigger number. And so we will using this activity series to test it out for our coming experiment. Now I'm going to put this activity series in a listed form. Instead of a horizontal form, I put it vertical, but the same order of the most reactive on the top and the least reactive at the bottom. And now I'm going to test it out by different reaction. I'm going to test it out by see how this metal react with acid, how does it react with oxygen, and how does it react with water. And so to demonstrate this importance of more reactive and the least reactive difference. Now let's start. On the most reactive group, potassium, sodium, calcium, magnesium, aluminium, they are all the most reactive metal. If you see how do they react with acid, oxygen, and water, and here's the outcome. They quite violently react. The first one, all this reactive metal, if you met with even a dilute cold acid, it can be explosive. It can be explosively react. The next group, oxygen. If this highly reactive group react with oxygen, the metal can burn. The metal can burn. And this is a typical example we use to cutting a strip of magnesium and light up, and they will give a very glowing white light. And same apply to most other metal. They will give a different color, but they will be highly reactive. Next group. If you put a piece of metal, this pure highly reactive metal, onto water, that is how you will look. They react quite violently. So you can see this highly reactive metal, which correspond to those ionization energy with small number. Now let's look on to the next group. If you look onto the lower group, this lower group also will react, but the manner they react will be different. Let's see. And now let's see the middle group. How do they react with acid? You can see on the upper group. This upper group, if you put cold dilute acid, they will react. But if you go a bit lower group, the less reactive group, they will react, but you need to warm up the acid a bit more. So now let's see. So this is an example. This acid been wait for 1 hour, 2 hours, 3 hours by putting a piece of metal strip inside. And you can see they react, but take more time. So the reaction will be slower than the previous one, which is explosively react as to the more reactive metal. Now let's look on to the oxygen. Oxygen. Does metal react with the middle group of oxygen? Yes. Condition. If you can see the iron rusting. Iron rusting is the reaction of metal react with oxygen. But if I want the reaction faster, can I? Yes. If you can divide the metal into a fine powder, you can make the reaction react quite fast. Or another way, you make the environment in pure oxygen surrounding, pure oxygen. As you know, our room at our environment, there is 21% concentration in oxygen. But if you change these two conditions, you can make the reaction quite fast. Otherwise, that's what will you see as this middle group metal react with oxygen. The next group, does metal react with water? Depend on the temperature again. If it is very hot water or in a superheat steam, look, water when it go up above 100 degrees, they are no longer as a liquid state, they become steam. And if you add another up to 1,000 or high temperature, they still in steam state. So, and that's what we call superheat steam. This superheat steam, they can react. So you can see, does it react? Yes. If you put the water to that high temperature, yes, you can see the reaction. Otherwise, will be very, very slow. So this is to demonstrate the difference of the upper group and the middle group. And now let's look on to the lower group. How would they react? As the clue is, remember, the lower group are less willing to give out the electron, unreactive. So the answer of this group is no reaction, no reaction, no reaction. No matter you put into the hot acid or you put in a pure oxygen, finely divide, or you put onto the superheat steam water, it doesn't make difference. They will have no reaction. So this concluded this activity series corresponds nicely with the ionization energy. The top group, they fastly react. Middle group, they react but are quite conditional. They have high enough temperature, high enough concentration, or enough surface areas to contact and react. This will increase the rate. The lower group, no matter what temperature, what condition, it will have no reaction. And this explains about activity series of reactive and the unreactive difference in metal. Now let's look on to the other aspect. We look on to, okay, if it reacts, what will form? Now we will consider, in case if no reaction, nothing will react. But in case it does react, what will happen? According to the rule, if it is an acid react with metal, we should form hydrogen gas, salt and hydrogen gas. The next group, if metal react with oxygen, it should form metal oxide. The next group, metal react with water, will form metal hydroxide with hydrogen gas or metal oxide and hydrogen gas. So, on the first group, you can see they form if they react, it doesn't matter what metal with what acid, the formula will be the same. They all form into some type of salt and hydrogen gas, unless they on the bottom group, no reaction. If you're on the next row, metal react with oxygen, it should form metal oxide. No matter what metal, if it forms, you can write the equation and you know what type of metal oxide. If no reaction, on the lower group, no reaction. Next group, the reaction with metal with water will form metal hydroxide plus hydrogen gas or metal oxide plus hydrogen gas. Or otherwise, the lower group, no reaction. So on this list of active metal to unreactive metal, and plus these three types of reaction, they nicely summarize over a few hundred different experiments, and they all summarize it into a simple table form for you, and so to give you the trend of reaction. So you can see look at this trend. You can actually, it is a summary of quite a few hundred different experiments, and it nicely summarized. Thank you.